can't hear myself speak. I think that should be about it. So, thank you so much for coming along to tonight's Not So IoT. Before we get going, if I can get my slides to go across, we do have a code of conduct. Really, that bottom right-hand heart emoji down there, be kind and considerate, kind of covers everything. If anybody feels as though they're having an issue and the code of conduct has been broken, then by all means send me a direct message here on Zoom, and then I'll attempt to put that situation correct and keep you up to speed with what's happening with that. But we run a really nice meetup, and the folks that come along are lovely anyway, so not a problem. We're sponsored tonight by, on the bottom right hand corner, Rebel. They're sponsoring the Zoom that we're currently using. Otherwise, we'd all be shouting very loudly at each other, and it wouldn't be as fun. Also, Raspberry Pi, they support us by giving us some swag every now and again as well. They're fantastic. If anybody has spoken to me before, they'll know I love Raspberry Pi and the stuff that they do. So they're awesome. And also, I have a freelancing company that runs in the background, even though I work full-time for Avanade, that sponsors the website and emails and any hosting fees and stuff like that. So that's why that appears on there. I'm also a Microsoft MVP, as is John. So 2/3 of the people on this call, in fact, are Microsoft MVPs. And specifically for you, but anybody else watching, if you're interested in becoming an MVP, then do by all means reach out, and we'll explain what that process looks like and what the advantages are in being a Microsoft MVP. But for us, it's exciting, certainly this time of year, because in 2 weeks' time, we'll be heading across to Seattle, to Redmond, to sit with the Microsoft PGs and learn about all the cool stuff that's coming soon at MVP Summit. So that's always a really good week, full of lots and lots of geeking out and lots of trying to find where the next event is. So yeah, it's always good value, that is. So tonight we've got Jon Mikel Inza. Is it Inza I'm pronouncing your last name as, by the way?
Yeah, Inza. Yeah.
Yeah, good. Always good to check. I'm talking about IoT device simulation tools for development, and I've already had a sneak peek. It's good stuff. I love all the stuff that John's going to be talking about. Coming up, we've got Cliff Aegis coming next month. This hasn't been categorically defined yet, hence the TBA. But Cliff's always really good value to watch. He's got some really great stuff that he talks about. So I'll get that up on Meetup and announce it soon, and folks can come along to that. So, and that's it. So you don't need to listen to me waffle anymore. At that point, I will stop sharing, and we can switch across to John and let you do your part.
Perfect.
As there's not that many of us in the chat at the minute, I'm sure just, stick your hand up and come off mute at a convenient time if you got a question there, Richard, or if you don't fancy doing that, by all means, stick it in the chat and I'll come off mute and interrupt John myself.
Perfect. Tell me if you see my screen. I'm sharing now.
I'm sure it's coming. Yeah, I can see it. There it is.
Perfect.
Good stuff.
Start with the slides.
I'm going to go on mute and leave you with it. Thanks very much.
So is it okay? Do you see my screen? Is it okay? Okay.
Yep, all good. Okay.
Perfect. So thanks, Feed, for having me. It's really a pleasure being here. We know each other from a couple of years now, or maybe a bit more. So thank you for that, and thank you also for your contributions and what you do for the community. I truly wanted to start with that because otherwise I'm taking the risk of forgetting that at the end. So I truly wanted to do that because I know you put a lot of effort on that. So yeah, now it's said, so I can start.
Really nice of you to say thank you.
Yeah. So the idea today is to talk about a common need that IoT developers might face at some point in while they're developing IoT solutions, especially when they need to validate flows. I mean, generally speaking, and what does it mean? We are talking about validating, for instance, provisioning, validating telemetry, validating schemas, validating types of messages, validating interactions between the cloud part, the solution part, and the devices, because we tend to think that, for instance, that IoT is only about devices sending data to a solution, but solutions can also interact with devices in the other direction. Um, and we can also be talking about how to generate data randomly and consistently to validate all those flows, how the solution is fed with logical data, and all that, not only with one solution, but with many solutions at the same time. So that's where I started thinking I had to do something about that. And it's also true that we all have been maybe using small physical devices to simulate those parts and implement those things what you mentioned earlier, Pete, Raspberry Pis or ESP32 within the Nano framework or devices like that. But those solutions, which are great, in the end, they're not truly manageable when one developer needs to deal with that in many situations, with many different projects, and in a scalable way. And when they need to share all those tools or all those configuration or devices with other projects, other teams. So that increased my need of building something or starting to think of building something more shareable, more reusable. And that led me to build a set of tools. And the simulator I'm going to present today is one of them. So before going deeper into the details of the simulator, I'll review a bit, I'll remind or view for those who don't know what IoT is, the main concepts of IoT and IoT solutions, and how it translates in Azure or Microsoft technologies to put a bit the ground and explain where the simulator takes place in all that landscape. So conceptually speaking, let me take the pointer here. The IoT solution starts with the devices, with the IoT part, the thing part in the Internet of Things. And you can find different types of devices, very small ones with MCUs or SOCs, limited capacity in terms of communication, processing, or memory. As slightly bigger ones with more capacity and communication. They can run richer processes and store more data locally and process it locally. And another category of way bigger, still called devices, but they're actually like huge computers or big data centers with orchestrators and containers and that run. They have huge capacities to run local, very intense logics and very business expensive logics, and even local clouds, etc., etc. So we are talking conceptually, and there also, we can find more types of devices, but let's say for simplifying that there are those three types of devices. Next to those components, the device side, we have another component that provides an identity, the identity of the devices, and that enables the devices to communicate with the rest of the solution, which is called, the fact of giving that identity, which it's what is called the provisioning. So there is usually a component in charge of that provisioning. Once the device has its identity and it's authorized, he can interact, and I say on purpose interact because the flows can actually be bi-directional, not only in one sense. With let's call these hubs that collect the data or interact or send the commands messages back to the devices. And once the data goes through those hubs, it can be processed or stored by other components to extract value. So, and they're divided in different types of components like raw storage, value extraction, near time extraction, also real-time value extraction with different architectures, integration, taking that value and integrating that value with other systems, and so on. So this is conceptually what an IoT solution is. It's a bit abstract, so now we are going to see how it translates in actual Azure services or Microsoft technologies. By the way, if you have questions at some point, feel free to interrupt. No worries about that. So again, if we go through the devices, if we start at the device level, the small devices are usually they usually have firmwares coded in very low languages. So there is no real Microsoft technology for that, except the Nano framework, co-created and co-maintained and co-developed by one of our friends, Jose Simoes. So hi, if you see this recording. Uh, and for the mid-level devices with a bit more capacity, we usually find IoT Edge, which is a great solution to embed that part of the IoT logic and compose that logic with modules and make slight processing in the edge part, of the device before sending the telemetry to the cloud. And for the devices who have a lot of more capacity, we are talking nowadays about IoT operations, which is a new, not a new solution, but a more recent solution than the other ones built by Microsoft a few years ago to cover part of the market that they were not covering with with IoT Edge or the other solutions. So that's the device part. The component who is providing the provisioning to those devices is called a DPS, Device Provisioning Service. And every time a device sends a request to that component, it provides an identity to the device, and the device is, in a way, linked in a very simplified way of explaining this to an IoT hub behind that. So in IoT solutions, we can find one or more IoT hubs behind the DPS. And the DPS can decide to which device to which IoT hub the device can be linked. So there are different ways of configuring that. It's not the topic of today's session, but you could talk very long about this. So I try to go a bit fast about that. So now we are at IoT hub level, and when the telemetry reaches the IoT hub, it can be routed according to different logics and goes through the IoT hub and reaches the different endpoints in the IoT hub. And those endpoints are consumed by all the other services we have been talking about behind. All the other components we have been talking about and translated into services. They are services like Azure Storage, Azure Data Explorer, Azure Stream Analytics, Event Hub, Service Bus, Azure Functions, and a very, very, very long catalog of services. It's hard to provide a generic solution in IoT for all the projects because all the projects are their specific needs and as an architect, we need to take into account the requirements, but also the cost, and to try to adjust that to the size of the value we need to create and at which cost. So that's why it's hard to build a generic solution because it truly needs to be tailored to the need. I'm also mentioning or showing here two other services, more probably newer. Fabric and Foundry. Fabric is a huge a huge family of devices that collects a lot of things related to data and value extraction from data to make things simpler for, let's say, data consumers and those who need to extract value from that data. Sander, another colleague, another friend, knows a lot about that, so he can help us or help whoever wants about this. He's very, very, very knowledgeable about this, um, especially the real-time intelligence component. And also mentioning Foundry because at first I was slightly skeptical about AI and that trendy, the huge trend of AI services with no clear value or no clear way to extract value and to monetize it and to make it profitable. But AI Foundries is starting to change that. So I think it's important to mention it because it can truly add value to your applications or to your solutions. So that's the last service. Um, Now, if we focus a bit more on the device side, because that's what we are talking about in today's session. If we take the device, as I've said, it needs an identity to communicate with the solution. So it tries to provision with the DPS. The DPS creates that identity and connects the device to an IT hub. And at that point, the device can start sending telemetry or messages to the IT hub. And the IT hub can also send back commands or messages to the device, creating that bidirectional flow I was talking about. Why I'm repeating this and underlining this? It's because the simulator we are going to see implements exactly all this within a MAUI application. So it can truly replace all the flows of the device. So here in this slide, I remember what I've just said. So I go a bit faster. You have a small list of the Azure services you can find in a IoT solution. And this is not like an exhaustive list because, as I've mentioned, solutions, IoT solutions can change a lot, but you'll probably find at least these services. I make a special mention to Azure Device Registry, which is a new way of managing identities. It's still in preview. That's why I haven't included it in the diagram. But it's worth it taking a look and to see what is going to bring us value when it become a GA. So if we go back to the device side and we remember what was the why, the need, the starting point of the device of the simulator. Sorry. So it was a way to solve the problems that IoT solutions developers were facing when they're building solutions, IoT solutions. So what they needed, let's try to sum up that to understand the next points. They needed to have a way to have different devices with different DPSs. Now we know what services are being used in IoT solutions. We can put names to those services. So they also needed to have a way to validate different types of provisioning. There is not only a way of making the provisioning. There are many ways. Group provisioning, group enrollment rules, individual enrollment rules, with different types of rules for each provision and different types of configurations for each type of provisioning. So it's very handy and very helpful for developers to have a way to persist that and to keep devices configured or devices or DPSs configured that way. They also need, or ideally, they would need ways to validate DPS configurations in terms of twin properties, which is a concept related to IT Hub and the SDK provided by the to integrate the IT Hub with devices. And all the flows, all the linked flows like desired and reported properties. It will also be nice to have a way to send different types of telemetry. When I say different types of telemetry, I'm thinking of different types of messages depending on the project. Maybe cars will send very specific types of messages, usually small ones. a robot can send other types of messages, richer messages with more data, with different structures. So it would be nice to have the capacity or a way to configure that somewhere, somehow, and to reuse that. And last but not least, we have, developers will need to have ways to validate different types of interactions. And again, interactions doesn't mean sending telemetry. It's also receiving messages from the cloud or receiving orders from the cloud, um, and according to different types of logics. So this is a way to remember the need, the starting point, and let's see what the application actually does. The application allows to add many DPSs, so we're starting, it's a good starting point. After adding those DPSs, we can provision as many devices as you want, which is great. And each device can have its own simulation settings, so it also answers to the needs we have been viewing. And most of the D2C and C2D, D2C means device to cloud, and C2D means cloud to device features in the IoT C# SDK are implemented by the simulator, which means that the provisioning with SAS and certificates is implemented. Sending telemetry of different types with JSON schemas is also implemented with a small logic. The randomness of the data is quite simple, but it's still configurable with JSON schemas. It remains very useful. The device twin reported properties is implemented and managed. And the device twin desired properties is implemented and managed too. The methods are implemented too. And you'll find here a link to the whole documentation of how it's implemented and how it can be used. No worries, I share the slides after the session with Pete, and you can find them through the different posts. So no worries about that. And simulator also implements the C2D messages. So we are going to see all this with the demo. No worries, it's not kind of fake. You don't have to believe me when I try to show all that. The simulator has been implemented with Maui. This version of the simulator has been implemented with Maui. I started doing it with .NET 6, and I've been upgrading it until .NET 10. And now the solution has become open source, so you can find the source code in GitHub. The link is also provided with the slides. You can do whatever you want. You can contribute if you want. So feel free with that. Have other versions of the simulator with containers and other types of hosts. We have more features, but of course, being in a mobile application, I couldn't put everything in the mobile application, otherwise it would be a problem. Um, so that's it. Let's go into the action. And those are the screens. I present the screens before doing the demo to make it a bit easier to follow during the demo. So this is the first step: how to add a DPS. So this is the initial screen, and when you click the plus button, you can add a DPS. You give a name. You have the URL here. It doesn't. It never changed. It's the same for all the DPSs in the world. It's still configurable, but it's provided by default. The security type, either SAS or certificates. Managing certificates with Android with Maui can be challenging. Honestly, it doesn't work. It's not super stable. You need to create certificates in a very specific way, otherwise it doesn't work. But yeah, the SAS way of doing that, it's still stable. The way of how to create the certificates is described in the GitHub documentation. You can find in the links provided with the presentation. So that's why I hope to avoid you a lot of nightmares finding how to create the good certificates to use with the devices. The enrollment type, it's forced to group because I according to the needs I had in all the projects, I never had a need to create individual enrollments. So I prefer to force that to with group enrollments, and that was yeah. Let's say that's was my decision. It's not. I don't know if it's good or not bad. That it's the way it is. And these are the main, let's say, the important parameters to create to add a DPS. The scope ID is something that can be found in the Azure portal. You see it during the demo, and the primary key, which is also provided by the portal, and you see it in the demo. After that, we can save the settings and created a provisioned device following the logic we have been seeing in the first slides. So to create a device, we choose the TPS, we give a name to the device, and we click on provisioning, and that's all. Everything is done for you by the application. It gets a connection string. It is in this version of the application is displayed for control. I mean, I understand that if the purpose would be another one, we should at least hide part of the connection string because well, it wouldn't be secure. But in this version of the application, you can see the whole connection string, so you can control that everything's okay. It is properly provisioned. So again, once we have provisioned the device, we can provision another device if you want, and you can have as many devices as you want with the same DPS. And if you want to start simulating something or flows or the interaction with the IT hub, you only need to go to the next step where you set the simulation settings. So you can choose among all these settings, telemetry. Telemetry is represents the device to cloud messages, and C2D messages. Next to the C2D messages, you see the C2D direct methods. Below the C2D twin properties. Next to that, the C2D desired properties. All these are IoT hub concepts. So to understand properly what it is and deeply what it is, you need to understand a few concepts of IoT. But very shortly said, the C2D messages are the messages that the IoT hub can send to the device. The C2D direct methods are the methods that the IoT hub calls inside the device in a synchronous way. Messages are asynchronous, direct methods are synchronous. So the device needs to be connected to make the call. With the message, you can send a message. If the device is not connected, the device will receive it whenever he recovers the connection. The twin properties is a concept to manage the delta between in terms of configuration between the device and the IoT hub. The IoT hub tells the device, I want that you have this configuration. And the device can say, I have this configuration. So it's a way to measure the delta and to trigger or apply logic depending on the delta of that configuration. And these are properties, it's part of those twin properties. The file upload is another feature. I implemented it, but I never use it. So it's a way of sending telemetry by batches. You send a set of messages together instead of sending a message whenever it's created. And another parameter, you can configure the how often you want to send the telemetry. So it's a number in seconds. And that's all. Once you configure that, the only thing you need to do is to define the JSON schema to create the random telemetry. So clicking here, it opens a window, a dialog to choose that JSON schema. Once you have configured all this, you can save it and it's over. You click on start and the device starts sending telemetry. And you have two screens, the D2C screen and the C2D screen, where you see logs and whatever happens. So that's basically what we are going to see now in the demo. Any question? Everything clear so far?
All makes sense to me.
Yeah,
Perfect.
got was there one question? You might come on to it later. Is it possible to simulate with this packets of data coming across in the wrong order, some of them being delayed, some of them getting lost in transmission, and to understand what would happen in those cases?
What a good
Um,
question that is. Love
Yeah,
that.
very good question, honestly. It's true that this application, this version of the application assumes that everything goes perfectly. No package lost, no messages lost, no incidents. A way of creating incidents is to starting and stopping the simulator. But if you want to apply your own logic, it's quite easy to do, knowing that the source code is shared and you can only replace the simulation service with your own simulation implementing an interface, and you can add the logic you want, even connect that logic with external libraries or external APIs with richer simulation logics like ANSYS. I'm talking about industrial simulation and with digital twins, device twins, and those kind of things. But that's possible doing it, implementing the interface, documented in the GitHub repository. But this version of the simulator, it's quite simple actually.
Great, thank you. I'll have to take a look at the GitHub repository and play with it and see what it does. Thank you.
Yeah, good. So let's start with the demo. I'm going to stop sharing the slides to start the demo. Do you still see my screen? Is it okay? Perfect. So
Yep.
this is the Android emulator installed with Visual Studio. I've installed the application. So this is the application. By the way, the application is available at the Google Play Store. It was available, I mean, at first and when I created it, but I had to retire it because I had an issue with Microsoft related to trademark, because I was mentioning in the description Azure, and I had the Azure logo with no authorization. So I had to retire the application and I had published it back. Uh, so you can install it from the Google Play if you truly don't want to get the source code, compile it, and to push it into your phone. But if you want to play with it, you can get the source code and play and do whatever you want. Which, I mean, in the end, it's funnier. um, so this is the simulator. We are going to create to add a new DPS. So I mean, the normal way of doing this is clicking here. You'll see in the GitHub report, I created a script to create a QR code for the DPS, for the DPS settings. So if you have a real phone, you can click here and take the picture of the QR code and it adds the DPS directly for you, instead of having to add all those secrets, which are always hard to add, long secrets. So um, I'm going to add here Maui DPS 1. This URL is still the same. Won't change it. Symmetric key for the security type. Uh, the scope ID. The scope ID, you can find it in the IT in the DPS portal. Sorry. So this is Azure. This is DPS, and this is the scope ID we need. So copy it. Oops, didn't work. Yeah. And the primary key needs to come from the enrollment groups. So in the DPS again, we go to manage enrollments. As you see, I have many of them, but we are going to create a new one. Sorry, oops, create a new one. Symmetric key for SaaS, or otherwise with certificates. But for the demo, I'm going to do it with a symmetric key to be faster and simpler. Maui demo 1 enrollment group. Here you can find different policies of making the provisioning. So you can decide to never make the provisioning, which is, I never use this, but these two are quite useful. You can decide to reset all the settings in the device whenever you make a provision of a device, because you can provision a device as many times as you want. Or otherwise, you can migrate the settings of the device in case the IoT hub changes when you make the provision another provision of the device. So, I keep it this one. Here we link the IoT hubs we need to be used to make the provisioning. Here I only have one, but you can have as many as you want. And just below, you can define the rule, the business rule, the logic to follow to decide in which IoT hub will be used to create that identity. Usually I take this one, the evenly weighted distribution, but you can also, if you have a very, very, very large solution, it's maybe wiser to choose the IoT hub, the closest IoT hub to the device for latency issues, and so on. You can have your own logic if you connect an Azure function behind with business logic and so on. This is the device settings. This is something I really like, and nobody uses it. Nobody. Not a lot of a lot of people uses this, but I found it very useful. So we are going to create a few tags here. Device type, for instance, Maui simulator, and desired properties. A simple one. Let's say version. Oops. 1.0. That's the preview service I've been talking about earlier. So we skip it for now. And that's it. We create the enrollment group. It was this one. Here I copy the primary key. We can add the secondary key, but it's not mandatory. And that's it. Let's save it. Now I have another DPS here. If I want to provision device, I just need to click here or go to this menu, devices. Both do the same. Here, you can choose the DPS you want. I'm going to choose the one we have just created. And we need to give an ID to the device. Let's say demo device 1. And provision device. And in a few seconds, it will provision the device and create the connection string. I'm seeing that here I have an issue after the upgrade. The ring, the sunglass is below the button instead of being on top. It's something I need to fix. So this is the connection string. With this icon, you see that the device has been provisioned. So we save it. And now you can see it at device level. Here you see a demo device, which is provisioned. If the device is not provisioned, this icon doesn't appear. We can create another one to show you that demo device 2, not provisioned this time. Save, and you see you can know what devices are provisioned and what devices are not provisioned. So now, next step, let's take the device we have just created and create a simulator. So you can go through this button or go to the home screen where all the simulators are listed here. And we can choose telemetry. I'm going to pick them all to show you how it works, except the file upload, because I don't have any file to upload. I'm going to put a smaller rate. So every 5 seconds, the simulator will send a message. And now I just need to choose a schema. This schema, I have a few of them I have already uploaded to the device. So this is a normal JSON schema is nothing special about this. You can find and see the properties that are going to be created: timestamp, schema version, message type, temperature, pressure, and humidity according to the rules defined here. And that's all. That's all you need to do to configure your simulator, and click on start. And you see the telemetry that it's going pushed, and this is the C2D messages received by the IoT hub. So quite simple, and yeah. But the demo is not finished at this stage. Now we are here. I mean, we have seen how to configure the DPS, how to add a device, how to provision a device, how to configure the simulator, how to send the telemetry. Now I think it's wise to, or it's worth to show you the C2D part. So if we go to the IoT hub, this is the DPS, and this is the IoT hub, the connected IoT hub. If we look for this device, demo device, here it is. So first proof, it has been created in the IoT hub, which is great. And let's say I want to send a message to the device. Send message, and the message is here. And which is quite impressive, and the work done by Microsoft, I'm truly impressed by what they have done, architecturally speaking. You see the speed, and this message is going from my computer to the IoT hub, to Azure, in Azure, and from the IoT hub to this device inside my computer, and it's almost real time. So which is amazing. Let's send another message. Up. Test 2. So it's very, very, very fast, which is impressive. And here you can set whatever type of message you want. And and we are talking about messages, asynchronous. So if the device is not connected, the message will be sent, and whenever the message will recover the connectivity, it will receive the message. So now let's use the methods, which is another very powerful thing. Set telemetry interval. This is an already implemented method inside the simulator, so you can change remotely this parameter, this one. So here you see 5. I put, let's say, 15. Invoke the method.
I think there was a spelling mistake in set telemetry interval.
Oh yeah, okay, yeah. Sorry, yeah, good. I wasn't finding. Very, very good very good site. Thank you. So invoke the method, and it's immediate. The configuration has been updated, and you see here below the request. Let's put another value to show that it's not that it truly works properly, and 30 and 30. And it's local. It's not local. It goes through the IoT hub, through the cloud, and it comes back to the device. So it's very, very fast. The simulator also takes into account generic direct methods in case you need to implement, I don't know, to simulate a reboot, and you have your own payload. Let's say with this. So you can send this, and the simulator is still taking into account all that, and it show it. It won't make any action, but it'll show the log in the logs, the method name and the payload. So, oops. Well, I have an issue with the payload. It should be shown. Oops. No, mistake. have a regression here. But yeah, you should see the payload. Let me check if I put something else. No, it need to be JSON. it worked before the demo because I tested that exactly. Let me check.
That'll be another
Reboot.
typo.
It's okay. No, something is happening. Well, okay, I need to fix that. Another
Hmm.
issue to fix. There's no okay. No, I need to fix that. So, you get the idea. You can call whatever method you want to call. You can call this, for instance. Ah, okay, yeah, no, okay. No, the reboot. No, I understand. The reboot is it's already implemented in the device, but the generic one takes the payload. So yeah, it's not a bug. Sorry. Up. Don't you see it here? Okay. So that's it. So this is what the simulator is. This version of the simulator. Of course, you can stop it and start it whenever you want. You can stop it. You see the number of messages sent. You can control that. And if you want to start again, you click start and it starts sending again the telemetry. If you need to add more simulators or more devices, it's pretty easy. You click here and you add as many devices as you want to, and the same for the DPS. You can add as many DPSs as you want with different configurations, with SAS certificates, different settings with the device twins, and so on. That's something I wanted to show you also. If you go here, I don't know if you remember the properties we have set initially to create a device, but here we have the tags, device type, mouse simulators. This is something we have configured in the enrollment group in the DPS. So it proves that we have been gone through the DPS. We just create and through the right enrollment group we just added these tags and the proper tags and this desired property. So this is all for the mobile simulator. After this simulator, I have another one. Another. I mean, I have another version of the mobile application. Haven't shared it publicly yet because I need to be sure that I can share it because I've been using Teltonica's libraries. But I have another version of this simulator that instead of sending JSON, sends Teltonica. I mean, it sends the data serialized with the Teltonica codecs in binary instead of having JSON data. And that's the only difference. But I need to be sure that I can share it because one of the libraries belongs to Teltonica. So before doing that, I prefer to do things properly and respecting the intellectual property. So that would be the second mobile simulator. The Teltonica version, it's quite helpful when you want to simulate GPSs and embedded automotive things because it has a lot of sensors for cars, about the engine, the speed, the throttling, the brakes, and the state of the car, the GPS, all those stuff. And that can be simulated with this application and then, with the Teltonica codec. While the Teltonica codec is super compressed format of sending data, so that's why some cards use that format is to consume less bandwidth. That's the only reason. Besides that, other simulator have another two ones, which are really nice. And they can be run with containers, with a CLI approach. What does it mean? Instead of having a visual application, you can have a DevOps or an industrialized process that can run the simulator to start sending telemetry, and you can control that. And to stop that, and you can also configure that all the settings we have seen here can be configured in a CLI way. So I show you that now with the second demo. Um, This one is less visual. So this is the command. I'm going to start with 5 devices. So the command is a bit long, but you see that it's a Docker command where you create a container, you indicate the type of security you want to use, the protocol, the scope ID, the primary key we have configured with the mobile application. So the number of devices you want to simulate. Here we are not talking about only one. We are talking about many devices at the same time. And the prefix you want to use to name the devices and the format of the ID. You can also specify where you can find the JSON schema to create that random telemetry. And that's it. So this creates 5 devices fully simulated with D2C C2D device provisioned, and that's an telemetry. And you can do with each of the devices all the features we have been presenting with a mobile application. So you can configure the telemetry rate of each of the devices independently, the configuration of each of them independently, and so on. So 5 devices is great, but this is very useful when you really want to feed an IoT solution with all the data flows that need to go through that solution. So you can create hundreds of devices or thousands of devices only with one container, which is very useful. I mean, I have to confess, this version of the container made a lot of happy IoT developers. And the link to use this container is also provided in the slides. It's the container. It's at the Docker Hub. It's a public container. You can use it as you want. I haven't opened the source code yet, but I'm thinking of doing it because I guess that there are a lot of things to be done with this container and adding AI to this, and then my next project, my next MVP project, or let's say side project, I'm trying to add an MCP server to all this to use and Gen AI, ChatGPT, whatever, or GitHub Copilot to use this simulator, directly from the prompt without having to send all these commands. It's still in progress, but yeah, I'm pretty sure I'll be able to do that. Something I haven't showed, and to prove that the telemetry is really sent to other things, and I'm going to stop the container now and go back to the IT hub screen first. So here we should see, you see the number of messages have increased quite a lot. I'm going to refresh it. No, not refreshing. Anyway, and this indicator is not real time either. But I do it otherwise. I don't know if you know this application. This is another very good application for IoT developers. It's an application that shows the messages going through event hubs or service bus, whatever. So now I'm going to connect to the event hub behind the IoT hub and start consuming the messages. So these are all the messages we have been sending with the simulators. And you can see the detail here. To prove I'm not lying, I delete everything, clear. So no messages here. This is connected. So here it is. I use the last simulator and I start sending telemetry at a bigger rate. Let's say every 5 seconds. Save, start, and you see it's quite fast. As soon the message appears here, it appears here, and it goes through the mobile application, goes through the internet until the IoT hub. And after the IoT hub, it goes through the IoT hub, through the routings in the IoT hub. It reaches the endpoint after the IoT hub. After that endpoint, it reaches the event hub, and I'm connected to the event hub. It's almost real time. And here you see the randomized telemetry according to the schema we have defined here. So that's all. I don't know if you have any questions. I could add a lot of more demos with other tools. No, sorry. I have one other demo, quite cool demo actually. You'll love it also, I hope. And this one, it's no, I need to stop this. This is another version of the multi-device simulator. I've created an extension. It's a public extension for .NET, .NET CLI, and Visual Studio too. So you can find them either at NuGet, at the NuGet repository. The links are provided also in the slides, or at the Visual Studio Marketplace. It creates an Aspire solution integrating the multi-device simulator. So in case you want to create your own application, but with next to your application, the Aspire dashboard plus your simulator. So it generates all this source code, so it's ready to be used, and you only need to click here, either compile and execute, or run the application that way with Visual Studio or Visual Studio Code, or whatever IDE you want to use. This is the Aspire dashboard. So the simulator has been created here. These are the parameters we have been configuring with Docker command line. And you can change them here directly. And here you see the traces. And we have created 5 devices that they are already sending telemetry. You see here the different devices, D1, D2, D3, D1, D2, somewhere we should have the 3, and they start sending telemetry here, D1, 4, 2, 2, 0, 3, and they start sending telemetry. And that's it. So this is a very nice way of using the simulator with Aspire. And next to this, you can add your API, your Azure function, your whatever you want through an Aspire resource, and you can add it here in the dashboard, in the logs. You can filter whatever you want in the logs. So you have all the benefits that Aspire can bring to your solution. And that's all.
Very cool. You sure? No, not one more demo?
No, that was the end one. I could continue with other ones, but I don't want to extend the night forever.
I like it. You mentioned the newer services
Yeah.
for certificate management and that sort of stuff. Is that something you're looking at building, or?
Not right now. I'm more going to the AI part right now. But if at some point I finish the AI part and nobody has implemented that certificate management with the new services, I can consider adding that part, because it's another part very interesting too. So I mean, in the short term, I'm more focused on finishing the MCP server to use the simulator with Copilot or something like that. Yeah.
Mm-hmm. That sounds cool. Very good.
Thank you. That looks very useful. I've tried to use IoT Hub before, but I've got stuck because so I found that there was a lack of visibility coupled with my lack of understanding. I couldn't work out where things got stuck in the process, and this would be very helpful to understand that. So, well, thank you for creating that tool, and I'll give it a
Yeah.
try.
My pleasure. If you have any question, feel free to reach out, Pete, myself, or anyone in the community or MVP community. We all be glad to answer to you. No problem.
Yeah, and we're sort of working with you mentioned Teltonica devices. We're working with them at the moment as well too. And
Okay, good.
yeah, yeah, when you mentioned the Teltonica codecs, that was very, very familiar. So
Yeah, I published a library with part of the codex, which is a free library, but I need to be sure the other part of the library I can publish it because it's maybe a part of the code it's proprietary. I need to be sure. But the code I have used, let me share what is here. Yeah. Uh, this library allows you to serialize and deserialize part of the Tectonica codecs in C Sharp. Not all of them, because there are a lot of them quite complex, but the codec 8E, it's implemented. Yeah, here. Yeah.
thank you.
Very good. I like it. How much for that Tonica? Was that the tiny message size library Tonica?
Yeah.
Was that? How much smaller is that than something like Avro? Not that I know a whole heap about Avro, funnily enough, but Avro is designed for reducing the size of messages and compression and things like that.
Yeah, it's way smaller. The total,
Wow.
the codec, I mean, the Tonica messages are very, very, very small. I mean, the serialization is made in the very old-fashioned format where everything is super condensed and sent with codes instead of raw information. So that's why it's super small. It's not like the Avro messages, which serialize the content in binary, but it's the whole content is serialized in binary. With the code, I mean, the Tectonica codec, it's kind of translating the information into codes, and those codes translated in hexadecimal to make them even smaller, and the hexadecimals are sent in the packet. So it's very super optimized way of doing that, of sending telemetry. I mean, the drawback is that the messages can be super large. I mean, they're limited in size, so you need to take that into account.
Okay.
If uh, if I had to make myself a new choice and having to choose the type of messages to send by a car and not be limited, I'll probably use Avro or other binary formats like protobuf or something like that, with Bison instead of JSON, to be able to provide more information instead of those very small payloads and super optimized. But if companies don't want to spend on capacity in those devices and they really need to optimize their bandwidth in terms of telecommunication because they need to pay that, yeah, I mean, it's quite normal that they tend to use that.
Yeah.
Yeah, so one thing I noticed that those devices did was say if you're tracking where a vehicle is, they would send you more information at certain times when the vehicle was say cornering quickly or change direction than at other times when it wasn't, and use that to compress the bandwidth.
Yeah, I mean, the Tonica devices can also have that part of logic because they have inside part of that logic. But again, I would implement it with um, uh, probably other binary protocols if I had to make a choice, and I prefer to have more information and larger payloads than instead of having the Tonica very narrow and constrained. So yeah.
Very cool. I like it. I'm looking forward to the AI, the LLM integration. I'm assuming something like GPT model that you're going to integrate with that and be able to ask
Yeah,
it questions.
I try to do that, to do it more than with any kind of GPT. I'm very interested in adding this to GitHub Copilot and have this in Visual Studio and as an extension, and to be able to, through Visual Studio or Visual Studio Code or any other IDE compatible with GitHub Copilot, to be able to send orders to the simulator I mean, and through the simulator to send orders to the device. So you can very easily with a prompt create, I don't know, thousands of devices, sending telemetry and sending orders randomly to all the devices and collecting information, collecting the configuration of each device and so on. And if on top of that, Microsoft does the MCP server for the IoT hub, I'm pushing to them to do that. That would be nice too. Otherwise, I have an extension to create an API, a REST API of all the IoT Hub logic. It's also a public extension you can use. It will be quite easy to add an MCP server on top of that API to build ourselves that MCP server. So that would mean that we could have an MCP server for the devices and an MCP server for the IoT app.
I see what you mean now. Got you. Okay, like it.
So if I have time, I try to
Yes.
prepare that for the MVP summit, and we try to push them.
I like that. We can combine that with a glass of beer. Even better. Oh, very good. I like it. Very good.
So
Oh, well.
I hope it was interesting and helpful at least. And feel free to use the code, break the code, and improve it or adapt it to your need. And yeah, also feel free to provide any type of feedback if you have any. No worries. I'm always open to receive any type of feedback. Especially if it's bad, because it helps me to improve.
True. Yeah, very good. All right. Well, thank you very much, folks. I'll go ahead and call it a night there. Really appreciate you taking the time there, John. Really great presentation. Thank you so much.
Thank you, John.
I'm going to
My
stop
pleasure.
the live on YouTube now as well.